everyone, in this video we are going to finally complete our molecular geometry chart, and we are going to do that by assigning bond angles. So essentially what you need to do is go through your chart that we already established and just add one more column. So let's look at this chart. So essentially what we have is our number of atoms that are connected to our central atom, that's our first column. Then we have our number of lone pairs. Then our third column tells us what shape is represented by that kind of combination. So our first example is when we have two atoms connected to our central atom, and then we only have no lone pairs on our central atom. So what we do is we add up these two numbers. So 2 plus 0 gives us 2. So now in this column right here where we say our total, essentially what we are saying is regions of electron density. So we're saying where are the electrons? And so all we need to do right now is go through and add up all of these numbers, our atoms and lone pairs, to determine our total regions of electron density. So our second row would be 2 plus 1, which is 3, 2 plus 2 gives us 4, continue on, 3 plus 0 gives us 3, 3 plus 1 gives us 4, and then 4 plus 0 gives us 4. So what we can do is figure out that our bond angles are entirely dependent on our regions of electron density. But the most important thing you can do is figure out which one has 0 lone pairs. So the 0 lone pair value is going to be your concrete value, and it's going to be the only one we can give you a definite bond angle for. So let's go through these three what we just started. So when you have two regions of electron density, where you have 2 atoms on your central atom and 0 lone pairs, you have a bond angle of 180 degrees. It is a linear geometry. Now let's go to our next one. When we have 3 atoms attached to our central atom with 0 lone pairs, that gives us 3 regions of electron density, and that will give us 120 degrees between each bond. Last one, when we have 4 regions of electron density, where we have 4 atoms attached to our central atom and 0 lone pairs, that is going to give us a bond angle of 109.5 degrees. And yes, it is 109.5. I expect you to be that specific. Now, what's really cool about this is all you have to do is match up these numbers. Whenever you see 4 regions of electron density, you can always assume that we're going to be really close to whatever that number is. But whenever you have a lone pair on there, remember, lone pairs take up elbow space. They need room. All you have to do is take that bond angle and just say it's less than that. So let's look at this second to last row right here. 3 plus 1 gives us 4 regions of electron density. We know that this is our concrete number, so our bond angle would be less than 109.5 degrees. And this is literally what I would expect you to report to me, less than 109.5. I don't expect you to tell me it's 104 or 107 degrees. It's less than 109.5. So let's go up here. We have another one of 4 regions of electron density. So this again would just be less than 109.5 degrees. So we can continue on up. We have another one here that has 3 regions of electron density. We already set our concrete value of 3 to be 120, and so this value is just going to be less than 120 degrees. So whenever you're assigning bond angles, you just add up your total regions of electron density. You figure out what the main one is. It's either going to be 180, 120, or 109.5. If you have a lone pair at all, you just add the less than sign, okay? That's all there is to it. Good luck. Take care of yourselves. Drink water.